In this video, we're going to continue our journey of learning late objects in object-oriented programming in Java. So in other words, we've already learned the syntax. Now we're going to take a look at the principles of object-oriented design and understand why they are important through example. But first, we need a little practice on a not as good way to do things. And so in this video, I'm going to take a look at something called parallel arrays. If we look at our existing program, we can see that we have miles per gallon, gallons of gas, and odometer. And then we print some information out, and then we drive our vehicle 100 miles and then 60 miles. So we're essentially simulating what would happen to a vehicle if driven. We invoke this drive method that we made earlier, which simply updates the gallons of gas and the odometer for this vehicle. And we can go ahead and run this. And this works well if we have one vehicle. It'll give us some output here that indicates how far the vehicle went. So odometer updates to 160, not surprisingly. Gallons of gas goes from 10 to 0. And that works well in many circumstances. But what if we have multiple vehicles? What if we want to run the simulation on multiple vehicles? Well, one option, which is not necessarily a good option, and I want to show why, but one option is to do something called a parallel array. So note the lines up here I'm highlighting that I'm commenting out. We have a variable, and the variable has one value. Now the lines that I've just added below, we have a different kind of variable because we have these square brackets. And that indicates that this variable can hold multiple values. So when we think of a traditional variable, we think of one parking space in a parking garage or a parking lot. It can hold one car. But when we have an array, we have multiple parking spaces of the same type, and we can put multiple pieces of data in there. So I have three arrays declared here. One is called miles per gallon, one is gallon of gas, and the other is odometer. And you can see that each of them has three values. Theoretically, this would correspond to three different vehicles. The first vehicle would own the first value in each of these arrays. The second vehicle would own the second value in each of these arrays. And the third variable would own the third value in each of these arrays. The trick is it's a bit brittle because you see we have the data spread across multiple arrays. And that's where we're going to find that object-oriented design is very helpful. But nonetheless, we also notice that our drive method is no longer compiling because it doesn't know how to deal with multiple pieces of data. So let's fix this. We need to point the gallons of gas, miles driven, and odometer to a specific unit within those arrays that we just saw. We can do that with square brackets, and then we can put an index number in. So 0 would indicate that we're working with the very first vehicle. Why 0? Why not 1? Because in Java, we start counting at 0 when we have arrays and things like that. We don't start counting at 1. So see, I could run the program now, and once again, we're going to get the same output as before, because that vehicle has 20 miles per gallon, 10 gallons of gas, and 0 on the odometer, just like we had up above. However, we're only considering that first array element. We're not considering the other vehicles. But one more change I want to make, and then we'll run it. Let's go ahead and update this last line where we're printing out the state of the vehicle. And we'll fill those in with a 0 index as well. And now let's run, and at this point I'm expecting similar output as I had before. And sure enough, we see odometer 100, gallons of gas 5, odometer 160, gallons of gas 2. Incidentally, looks like I need to update one more, which is this initial print line statement, because that kind of gave me some funny outputs. I'll tell you what, I'm going to update this statement, and I'm also going to move it into our function below, and then we'll do just a little bit more refactoring. So you see right now, this function, or this method that we have, is looking only at the very first vehicle, but we want it to look at multiple vehicles, all the vehicles we have in those parallel arrays. So what we're going to do is wrap it into a for loop. We start by declaring an iteration variable, or something that will keep count. Next, we need a test, which means keep looping until this condition is no longer true. So I'll say I is less than 3. Remember, we start counting with 0 in Java. So 0, 1, 2 represents the three items in our parallel arrays here, 20, 25, 15. And then finally, we need something that's going to change this iteration variable every time we loop, and that's what we're going to call the increment expression, which in this case is I++, which means add 1 to I every time we loop. Now, I'm going to take these lines in my method and I'm going to wrap them in open close curlies, which means this is the logic that we're going to run with each loop. Now here's the cool part. You notice how we've hard-coded 0 in each of those array elements. Well, ideally it shouldn't be hard-coded to 0. It should be whatever index number we're currently working on. So it'd be nice if we had a variable that represented that, right? Guess what we do? That increment variable, the iteration variable I talked about, the one letter I, well, guess what? The first time through it's going to be 0. Next time through it's going to be 1. Next time through it's going to be 2. So it's going to match very nicely with each of these data elements we want to iterate over. So I'm going to take all these zeros and simply replace them with I, which is our iteration variable. I will say I normally use very descriptive variable names. One-letter variable names are considered bad practice. However, when you're looping and you have an iteration variable, the letter I is kind of a given as an okay variable name to use. So that one kind of has a special meaning. It oftentimes means you're within a loop and you simply want to iterate over something. So all of my hard-coded 0 indexes or indices are now 1. Let's go ahead and run this with 3 different cars. I also added to our output the iteration variable so we can tell which drive we're currently on. So let's take a look. Notice we run our first vehicle, which is the vehicle with 0 miles per gallon, 0 odometer. Then we run our second vehicle, the first trip. Then we run our third vehicle, the first trip. And again, you can tell by the odometer. First vehicle had 0, and we can confirm up at this array it had 0. Second vehicle, 10,000. Third vehicle, 20,000. Now we do this, so that was the first trip, which was 100 miles. Now we do the second trip, which was 60 miles, and once again you see, the first vehicle runs, the second vehicle runs, and the third vehicle runs. So this works, but it's not ideal for a couple of reasons. First of all, we have our data about vehicles in 3 different places because we have 3 different arrays. Secondly, we are associating the data together by using that array index. And it's very easy for this to change mistakenly. Let's say that one array is a different size and I accidentally add the number 5 here. Then I've changed the entire data for every vehicle thereafter. In other words, 8 should be the gallons of gas for our second vehicle, 12 for our third vehicle. But now we have this mystery 5, which is in that second position, or 1 if you're counting from 0 as we do in Java. And we have the 8 here, which now lines up to this. So you see that by changing something subtle in an array, it can break our entire data model. The other issue that we have here is notice I've hard-coded 3 because I have 3 vehicles. Well, what if I have more vehicles? I'm going to need to go and recompile and change that every time. I could forget to do it, and if I remember to do it, it's still a lot of work. So this is not perfect. What we'll look at in our next video is a better approach, which is using a true class that represents our vehicle or our car, and moving the state or the variables and the attributes that represent that into that class, and also using an array list, which is dynamically sized. Stay tuned, we'll find that that's a way to make software that is less error-prone and easier to maintain. Thank you.